This session is about how to write connected apps. I realized the name may be a little bit misleading. I didn't have an idea for a better title, but hopefully the description gives you a little bit more context. So today we'll be speaking about how to write Bluetooth Low Energy apps, like apps which communicate with peripherals over Bluetooth Low Energy on the iOS side. So we'll be covering on how to use Core Bluetooth. This is the go-to framework on iOS for developing applications which talk to other peripherals over Bluetooth Low Energy. My name is Mike, and I work at Intent. I lead the mobile team there, and I'm working there for over 8 years now. My anniversary happened just last week. Time flies by. If you've got any questions, or if you want to take a look at my open source contributions, here is my GitHub handle. And if you'd like to speak afterwards, after the presentation, my email is right here. So feel free to use it. Nowadays we've got a lot of applications which talk to other devices like over various wireless protocols, be it Bluetooth, Wi-Fi, or even audio. Like it's also possible to transmit data over audio. So the way it works is you transmit, like one phone, for example, transmits audio which is not hearable by the human ear, because our human ear has a very limited frequency which it can hear, and then the other device just listens to it and then decodes the data. This is pretty interesting. There are like open source SDKs out there, so like all of the difficult work is done for you. Coming back to the Bluetooth side, there is this movement called Internet of Things. Basically it means that pretty much any device out there can be connected to the internet and commit to a global context of things. So we've got all these smart sensors, we've got TVs, we've got power banks. Most of them have some kind of an operating system inside, and if it has an operating system, it means that you can control it from your phone or from your tablet or whatever your device is. Before we dive in and get our hands dirty with the code, I'm going to give you a brief introduction of on what Bluetooth is, how it works, and what Bluetooth is good and what is not good for. So Bluetooth is a protocol, is a wireless technology standard used for short-range communication. It works in frequencies pretty much like the Wi-Fi. The Wi-Fi usually nowadays works at either 5 or 2.4 gigahertz. So Bluetooth works at 2.4 gigahertz. It's the way that the data is transmitted and encrypted is subtly different in both the Wi-Fi and the Bluetooth stuff. But they share a pretty common range of frequencies. Bluetooth is not suited well for long, like large data transfers. The transmitted data speed is pretty low from my experience. So if you're planning to look into transferring large data over Bluetooth, you may use Bluetooth like in order to make the devices talk to each other. However, there are better protocols suited for this kind of stuff. Bluetooth has this notion called profiles. So profiles is basically a set of things, a set of standards that a given peripheral must meet in order to communicate using that profile. This is just a list coming from Wikipedia. So you've got like medical devices profiles, you've got imaging profiles, you've got mesh profiles, you've got like internet sharing profiles. So there's lots of things out there, and there's lots of things a Bluetooth-enabled device. However, in the context of this presentation, we're going to focus on the generic attribute profile, the GAT side. So the gap profile basically consists of services and characteristics. So like if our Bluetooth application, if actually can you guys hear me? Everything working from the sound type? Yeah, I think it is. Yeah, I'm not muted. Cool. Yeah, because sometimes you've got these you've got like sometimes you're on a call and then like you're talking, and then like hey, I'm muted and nobody hears me. So I just wanted to make sure that you guys can hear me. Okay, yeah. So going back. So in a GATT, when a device adopts the GATT profile, basically how it works under the hood is a Bluetooth enabled application basically has this thing called services. So and inside the services there are characteristics. So you can think of services as basically a piece of functionality that a given device offers, and the characteristic is just a property of that device. So for instance, I'm building a smart heart rate sensor. So the service would be the heart rate service, and the characteristic would be, for instance, the beats per minute that my heart is beating to. Or for instance, I have some kind of a temperature sensor. So the service would be the temperature service, and a characteristic would be the actual value of the temperature. So the service is basically like the piece of functionality, while the characteristic is just the property of that functionality. And for these properties, for the characteristics, the other devices which connect to that device, they can basically listen to, they can subscribe for updates, as well as they can write to a given characteristic. Of course, this is a very simplified model of this, because there are many different things involved in how and who can access a characteristic, who can write to a characteristic, and who can read from a characteristic. Like you can have everything flying in a non-encrypted manner, or even you can have a certain set of devices being able to read from a characteristic, but for example not write to it. But these are but there are many details involved in this. However, we're not going to cover all of them here. So in this model, there are two types of devices involved. So there is the central, there is the peripheral. So the peripheral basically advertises to the whole world. It says, "Hey, I'm here. My name is my name is peripheral, and you can connect to me if you want." So basically, how it works is it just sends this beacon, like this broadcast, every now and then, and basically you can configure how long these intervals last. So the more frequently a peripheral advertises its information, the more battery, then the more energy it's going to take, as well as it's going to be easier for the centrals to actually discover the device, because like if you broadcast very rarely, then the central may not be able to get the advertisement to get the advertisement packets and know that you're out there and you'll be able to connect yourself. I see that there are new people joining. I have an iPad right here, on which I have the chat open. So if you guys have any questions, feel free to write in the chat. From time to time, I'll be glancing from the presentation to the chat, just to make sure that everything is all right. Yeah. Yeah. Okay. Everything's right here. Let's get back to the presentation. Yeah, so the peripheral advertises, and the central device just collects all of these packets, and that's how they know that there are some devices in the vicinity, and once it wants to connect to a device, it just it can connect to a given peripheral which advertised itself, and then create a connection. And speaking of connections, there are actually two kinds of connection. There are two kinds of connections, and this is pretty important, because I've seen many developers out there who are pretty much confused about what kind of connections you can make in Bluetooth. And I think it's pretty essential for you to understand that piece of information as soon as you'll be jumping into these connected apps. So we've got the bonded communication and we've got the open communication. It may sound pretty confusing, but it's not going to be in a few seconds. So the first is the open communication. This means that two devices are talking to each other in an open manner. So there's no encryption involved. There's no pairing involved. So like usually when you think of Bluetooth apps, like the first thing that comes to your mind is pairing. So in this scenario, the two devices can and by pairing, like you probably think of this like when you connect to a car, like you have all this confirmation dialogue, like this device wants to pair with this one, and so on. So in the open communication example, like this won't be happening because there's no encryption going on, and this is typically used if you've got no sensitive data to transfer. So one example I came up with is for instance, like you've got power banks which are Bluetooth enabled. Like I have one somewhere over here. I think I lost it. So but now thinking of it, sometimes sometimes it may be sensitive information after all, because for instance, like you want to save the power bank charge for later on, and then like someone can just connect your power bank and say, hey, like you've got 100% charge, can you give me some? But I think you can understand the message. So basically, like this is the go-to thing if there's no sensitive data involved, and you just want two devices to talk to as simply as possible. The second one is bonding. So the process of bonding means exchanging the encryption keys which are necessary to establish an encrypted communication between two parties. And this involves data like characteristics which actually need some kind of an encryption, and like you don't want basically everyone to be able to sniff out your communication. So the first stage of this is exchanging the private encryption keys, and after the private encryption keys are exchanged and everything is ready for to establish handshake, then you can actually start to read the services, the characteristics, and everything else. And this actually requires consent from the user. So typically, like when you go to a car, like you pair with the car. So like usually when these things are happening, this is where the bonding takes place. Because inside the car, like you typically you transfer some contacts. So this is already a sensitive information. So you don't want anyone to read the contents of your address book, basically. So when it comes to iOS, core Bluetooth is pretty much the way to go when it comes to working with Bluetooth. So the framework is pretty old. It's been out there, I think, starting from iOS 4 or iOS 5. Right now we've got the much older iOS version, so you get the picture. So this is the way to go to deal with GATT profiles on the iOS side. It's pretty old, however, it's still one of the best Bluetooth frameworks I've worked with personally, and I've worked with dbus on Bluetooth on the Linux side. I worked a little bit on the Android side, and I think Core Bluetooth is pretty much a very pleasant framework to work with. However, like that being said, it was still written in Objective-C, so it doesn't follow all of the latest and greatest Swift patterns. However, in the next slides, this is totally not necessary. In the next slides, I'm going to show you how to make it Swifty enough. And so basically, going forward, I'm going to show you like some real life examples of some real life like problems I faced during my career. So like we won't be going like through file, new project, let's add core Bluetooth here. So I'm just going to show you like some real life stuff that you can include into your projects. Nothing is perfect. All of the tools have their drawbacks, and this also applies to core Bluetooth. So there are some limitations when it comes to core Bluetooth. So the first and most important thing is you don't have access to MAC addresses of the device of the peripheral you're connecting to. If you've got no MAC address, it means that you won't be able to you basically won't be able to identify the device based on the MAC address. What you get from the framework is basically just a unique identifier of the given device, and that's it. There are many hardware manufacturers out there which rely on the identification process to happen based on the MAC address. So if you're an iOS developer and you see that happening, like, you have to put a stop to this right now. The second is basically if your app works in the background, because in core Bluetooth your applications can still get some events in the background, but it basically will stop once user force quits the apps. And of course, as in everything with iOS, like there are some limitations. There are some limitations when it comes to how your events are processed. So this is decided by the system, and that's it. Like sometimes you won't receive them the moment they appear. Sometimes you'll receive them at a later stage, or sometimes you may not receive them at all. That's basically how iOS works. Yeah. So now. Time for some tips and tricks. So the first trick is typically in an iOS app, like you've got this onboarding flow where user is taken step by step through how your application works, and during this onboarding flow, you basically collect all the required permissions, and that includes Bluetooth. And there's a slight problem with that, because the moment you start to initialize the whole core Bluetooth stack, this is going to ask for permission on your behalf. So you have no way of programmatically requesting any permissions. So you need to initialize the core Bluetooth manager as soon as just when you need it. And in this example, I'm going to show you also how to basically set up your core Bluetooth stack along with tests and everything else. So yeah, let's take a look at some code. Yeah, code. Yeah, so this is it. Can everyone see the font? Look in the chat. Okay, nobody says anything, so I assume so. However, let's presentation. Oh, maybe like this is going to be a little bit more visible. Yeah. So the first thing, let's check how this app actually works. So the core Bluetooth doesn't actually work on the simulator, so you need to test everything on the device. So this is basically our flow. So first we've got an onboarding flow. You press continue. When you press start scanning, it's going to ask for the permission. And then it's just going to scan. Once you force quit the app and launch it again, yeah. So you've got it working again here. Yeah. Yeah. So let's take a look how it works. How it works under the hood. So the first things, let's take a look at the peripheral scanner. So the peripheral scanner is basically is basically the class which actually performs the scanning. Yeah, which actually performs the scanning. So we've got the initializer inside the initializer. We've got the block right here. So you may be confused why are we injecting the dependencies for the class using a block? So the answer to that is we basically need we got our own we got our own implementation of the delegate here. So the core Bluetooth still works on the old the delegate scenario. So for those not familiar, the delegate pattern means that when an object wants to forward some events to another object, it basically captures a reference to the object, and the object is usually an instance which implements some kind of an interface. So in this case, it adopts the protocol CB Central Manager Delegate. And whenever something happens, like it updates its state, it discovers a new device, it's just going to call this method. So we've created our own instance of the delegate. So like if we accept the central manager as it is, we won't be able to inject the delegate. So that's why we're accepting a block, which and in this block we're passing our own implementation of the delegate, and the caller is responsible for actually injecting the delegate. And we also have a first-class function here, right here, which pretty much does it for us. So we can rely on the default arguments right here. Yeah. So as I mentioned, we cannot the moment we initialize the central manager is going to ask for permissions. So we need to delay it until the moment we actually need it. So let's take a look at the UI. So this is our onboarding view. So inside the onboarding view, we've got a tab view, which basically has two views, and the stack and the second stack basically has a button which just starts scanning. And when we start scanning, it's going to ask for permissions the way we want to. And inside the content view, we basically have just a list which displays all of the devices. So as soon as the user completes the onboarding, at the end of the onboarding, we're going to hit start scanning, and then it's going to start scanning, and the results are just going to magically appear right here. As you can see, I'm using SwiftUI. So Core Bluetooth is totally compatible with SwiftUI. So like if you were wondering whether this is the right time to start dealing with Core Bluetooth with SwiftUI, this is the right time. Yeah, am I muted here? No, I'm not. Okay. Yeah. So let's go back to the peripheral scanner. Yeah. So inside the delegate, we're having combined publishers for any event. So like we've got two events here. We've got either new devices or the state updates. So inside the Core Bluetooth, like the CB Central Manager, we can only work with it once it's actually powered on. So this is a caveat. So we need to wait until it's powered on until we start using any of its APIs. Yeah. So that being said, if the state is not powered on, if it's not scanning, then we'll basically wait until it's powered on using combine right here. And if it's already powered on, then we can start scanning. We can start scanning as we do. Yeah, so that's it. Does anyone maybe someone has some questions? No questions. Okay, let's move on. Yeah, no questions in the chat. Yeah. Okay. Yeah. So now let's move on to some unit tests. Yeah. So let's see if they're working first. Yeah, they're running right now. Yeah, so while the tests are running, I'm going to walk you through how the unit tests look like. Yeah, so as you can see, this the dependency injection scheme like we used here, it's actually working like this. So basically, what we're doing is we're creating our own central manager, and the central manager, we need to create a fake. So this is for those not familiar. This is this is called a partial mock. So a partial mock is basically when we create when we create a mock this way. So like we mock out parts of the functionality, but the rest of the functionality is still not overridden. So this is why it's called a partial mock. Like a true mock would be like if we created like the fake from scratch. Yeah, so the tests have passed. So I'm not lying to you, like that they work. Yeah. So we create our mock here, and inside the block, we're configuring the delegate right here, and that way we can inject our own our own instance of the CB Central Manager. However, the peripheral scanner will inject its own delegate. It's going to tell, okay, like you have your own CB Central Manager. Here's the delegate. Go. Yeah, so we've got. I'm using quick and nimble for the purposes of this show. Yeah, that's pretty much how the unit test works. So like we're basically testing each and every scenario. Yeah, and this is it for the example. Of course, I'll be showing you. I'll be sharing with you all of the code that I shared here. Yeah, so that was it. Again, if anyone has any questions, feel free to post them in the chat. I will try to answer them. Yeah. Oh, I forgot this slide. Yeah, talk is cheap. Show me the code. I have just shown you the code. Yeah. So the second trick is you can basically use protocol buffers. You can use protocol buffers for transferring data between the peripheral and the central. So sometimes if you want to transfer like this simple data, like you can use basically like raw data buffers for this. However, sometimes you need a little bit more structured data to do this, and for that, the protocol buffers are pretty good way to do this. Yeah, let's make it a little bit bigger. So as you can see, protocol buffers have first-party support in Swift. This plugin is actually authored by Apple. So basically, how it works is you get these nice interface files. They're called protofiles, in which you define how the model looks like, and then you use their utility, and then you get a Swift structure for working with that. Yeah, so I can imagine that like one of your questions would be, okay, like I've got JSON. I've got JSON. I've got XML. Why would I use protocol buffers instead of like JSON or XML? And the answer to that question is protocol buffers are cross-platform, and they're also backwards compatible. So, for instance, if in JSON, like you're going to iterate on your schema, and then in a certain scenario we're going to remove a field, then older applications, the older versions of your application may not work with it anymore. Protocol buffer actually has support for this. And it's also the binary is actually less it takes less space than a JSON, so it's much more extensible, and also, as I said, it also works cross platform, and you've got a nice interface which pretty much defines all of the data model here. So you can have like a single protofile which is going to be used by each and every element of your platform. Yeah, so let's see it in action, maybe. we don't want Python. This. Yeah. So for instance, you've got something like this. So you've got a single entity, and then the output would be something like that. So you've got a nice Swift structure, which you can use, and the command for doing this is just this. So that takes the protofile as the argument, and it's just going to spit out all the Swift structures. Yeah. So that's it for protocol buffers. Yeah. Yeah, and I just showed you code, so yeah, enough blah blah. Yeah, and trick number 3 is actually from my experience, it's a pretty common scenario. It's a pretty common scenario where you develop both, where both the mobile app and the peripheral are developed in parallel. So this brings some limitations, as well as you're required to mock certain things, and like the way to work with this, from my experience, is you either use an app like Lightblue out there. So Lightblue is an app which you can basically install on your phone or on your computer, and it's going to mimic like some common scenarios, some common Bluetooth peripherals you're going to work with. Or you can just write an app on your Mac OS, which basically advertises advertises a peripheral and implements some of the peripheral functionalities here. So there are also SDKs in JavaScript out there, which for instance you can write some JavaScript code. You can deploy it on your Raspberry Pi, and you can have like all of this the cool experience, like a true peripheral experience. Yeah, so I'm going to show you some code. So that's going to be the central example. Oh no, it's the central I just showed you. Going to be a peripheral example. Yeah, so let's try running it first. Oh, not this. I'm going to run QuickTime. Yeah, so I'm just going to show you briefly how it works. Yeah, so we've got we've got the application right here. Wait, something's not working with. Wait, just a second. Live demos always look like this. Screen recording. No, not this. Movie recording. Oh, there it is. Wait, was it just one? No camera, screen. Oh, there it is. Oh, finally. Yeah, so on my phone, we're going to use an NRF Connect. So this is actually a very cool app, the NRF Connect. So it basically is like I call it like the Bluetooth debugger. So as you can see, you've got the example peripheral right here, so we can connect to it, and basically we can see all of the. No, we can't. Wait, one more try. Yeah, let's try that again. Yeah, so we're connected, and after we connect, we see all of the characteristics and the peripherals right here. Yeah, let's try using one of those. Yeah. So because as you saw, like we've sent some data to the peripheral, and it's working. Yeah. So the code is pretty much is very similar to what we've done on the iOS side. It just took like 50 lines of code, and with just 50 lines of code, you're able to mock certain stuff, certain functionality, using the same programming language, using the same frameworks as you would use on the iOS side. Yeah, so this is pretty much this is pretty cool. Yeah, so that's it. And the last trick I wanted to show you is actually how to debug. Like Bluetooth stuff. So when you're trying to Siri just turned on. So when you typically talk to hardware engineers, like the firmware developers, and you want to debug issues, the framework level messages are usually not enough. It's pretty much it comes in pretty handy. Like if you'll be able to debug the communication between the peripheral and the central. So I'm going to show you how to do that. So there's a dedicated tool called Packet Logger, and yeah. So once you start listening to the Bluetooth packets, like you can see this icon, this Bluetooth icon in the top left corner. So this means that there's some listening going on in the background. Yeah, there are all the devices here. There's my device. Yeah, so we can let's see if we can debug the communication between my device, my iPhone, and my Mac OS. Let's try to send something again. Oh. Yeah, so let's try writing again. Send. Yeah, so just send something again, and yeah, so you can see there's a write request here. There's the MTU exchange. There's the write response, and this is pretty much the right event that we just saw. Yeah, so you can here you can pretty much see step by step all of the things that my device and the Mac OS just went through. So this is pretty useful. This is pretty useful if you want to debug stuff. In my presentation, there are pretty much some tutorials on how to do this. So basically, just install this configuration profile, and then you install the packet logger, and that's it. Yeah, so that's how it's going to look like if you're going to be like listening to the packets. So like you'll be this hacker guy. Yeah. So last but not least, I wanted to share with you some of the common pitfalls. That we faced. The first pitfall is actually bonding. One of our customers, and I'm not allowed to say company names here, but it's a pretty large music making company. I'm pretty much sure you've heard of. So they said that almost 50% of the device returns on Amazon was due to bonding failures. So the problem with bonding here is if you've exchanged the encryption keys, everything is correct. But once one of the parties actually loses the encryption keys, they won't be able to create a secure connection. And the only way to cancel that is to forget to clear the communication from one of the parties, and then establish the bond again. And many people just don't know how to do this. They're not technical, so they're not expected to. That's one of the reasons. One way to go around this is actually use the open communication of the one I showed you previously. When you're using open communication, you've got no encryption in place, of course, but like no one is stopping you from encrypting stuff by yourself. So you can still use open communication. You can send encrypted stuff to the characteristic and decrypt them yourself. That way, you don't have to bond, and it's much more transparent to the user. and like there won't be any event of losing the encryption keys. Second pitfall is using the device name to identify the device. I've seen many projects in which people were identifying the device by the device name, and this is a big no-no. So first, from the security standpoint, everyone and anyone can pretty much impersonate the device name. So this is not good. As well as device names change. What doesn't change are the advertised services. So you should always use the advertised services if you want to uniquely identify the device. Usually when you're dealing with the GAT profile, you typically first advertise some services, and your application is written so that it uses this particular service. So it should rely on the service, not on the device name. The third one is when you're doing an app which connects to a peripheral, you're not in the driver's seat. So you're pretty the way your application works usually is determined by how the hardware works. So you have to be wary of that. Also, when you're estimating an application which does some stuff in the background, like multitasking, and stuff like that, make sure to add some buffers, because these scenarios are very difficult to debug from my experience, and they usually take more time. So, like, if you think you're going to do something in 2 days, just tell your client it's going to take 5 days. I always use this under promise and over deliver. So, like, I prefer to say that something is going to take me longer amount of time and deliver it faster, rather than the opposite way around. The next one is in the advertisement packets, you can send pretty much all information, like any information you want. And I've seen applications which were basically sending the whole application state in the advertisement packets. So this is a big no-no, because there are people that may try to reverse engineer your app, and the more information you're going to give, you're going to make their job much more easier. And last but not least, please keep the scanning and the peripheral specific logic separate, because otherwise you'll end up with a big bloated class that is difficult to test and difficult to use. Yeah, so that's it for my presentation. One last thing I wanted to say is, I've said this many times, that this core Bluetooth framework is slow, not slow, it's old, and it's not up to the latest standards. However, the Bluetooth protocol itself is evolving. There is Bluetooth mesh, there is Bluetooth audio, and there's lots of devices out there relying on Bluetooth. So I think this is we're entering a pretty cool times where everything pretty much has an operating system inside. I've even seen electric kettles with operating systems. You can basically use that to your advantage, and I think it's always cool. It's always cool to develop apps which talk to some physical peripherals. We're also, like, if you liked what I just showed you, if you'd like to work with SwiftUI or with Core Bluetooth, please, let's talk. We're hiring. And thank you for your attention. I think we got like a couple of minutes left. So, like, if you'd like to ask some questions, I'm here for you. Yeah. So if you don't have any questions, I'll be here during the after party. Yeah. So we can also grab a beer at the after party. Okay, I think there are no questions. I would like to thank you for your attention. Thank you for coming to my talk. It's been great. It's been great to talk to you, and yeah, and I hope I'll see you at the after party.